This is Andrew Wicklund with Project Risk Consultants. We're in step 7 of the risk analysis process, so we've gone through the histogram chart. We've seen that we have an issue with the schedule. Management said they wanted us to be 80% confident, and we're going to be 206 days late. It's unacceptable. They said, hey, you can't even report that or we're going to fire you. You need to tell me how to fix it. So your histogram chart is always telling you where you're at. What's my chance of success? They want to be 80% confident. Well, I need 206 days. You can't have 206 days. Well, I need to figure out how to fix it. So what we're going to do is look at our tornado chart. So once again, histogram chart, where am I at? I'm very late. I'm gone from November all the way out months into June. So what I'm going to do is I'm going to right click that activity. So this is for my final report, and I want to show my drivers leading up to this activity. So you can do this multiple ways. The tornado chart, if I just click it for under the reports menu, it's going to run it for the entire project. Now in this one I've got some liquidated damage hammocks, I've got some maintenance activities. So I'm using this final report as my reporting milestone. So I don't want to go in and run it for the entire network. I want to run it to see the drivers to that activity. Now, you can run this for child activities as well. So if you said, well, I want to see my engineering drivers, I could point to an engineering WBS or summary task, and I could show you the children underneath that. I could run it for the entire plan as well. So right now I'm going to go ahead and run this for logical predecessors only. So if it's not a logical predecessor, if it's not in the chain leading up to this, it's not going to show up. So if I see activities that should be here that are not, I know that's an issue. So what I can see right off the bat, I'm 206 days late. I need to know why. Well, to decontaminate structures, clean strip out, third-party contractors, external approvals. Those 4 activities seem to really be the big drivers. Now, if I look at it though, if I want to really, I need to save 206 days. The lower I go on that list, the less impact it's going to get. So these are my drivers. These are what's pushing me out. If I want to fix things, I really need to go to decontaminate structures. I need to look at clean strip out. So those would be the 2 areas that are just above and beyond everything else. The other ones I may get a little bit of value, but if I was playing what if scenario modeling, those first 2 would be the ones I'd really look at. Can I do something about them? Now maybe I can't. Maybe it's a stream of activities. Maybe I'm going to have to resequence. There could be all sorts of things right now. However, I'm going to look at this decontaminate structures. I'm going to double click on this bar, and I've got a risk event. 40% chance of a 50 to 150 day duration. So that's causing a huge impact. So this one's being driven by a risk event. And if I go back to this tornado chart, you can see these items are bolded up towards the top. So when you see a bolded item, those are risk events are tied to those. We could separate those out and show the risk events separately. If there's no bolding, no risk event is tied. So red items that you'll see on here are going to be your risk events. So I can see the risk events on here as well. So delivery overrun, system failure, etc. So you've got a task and a risk mode in the bottom left hand corner. Now because of the way that Primavera Risk does some of the linking, some of these risk impacts don't link in like they should. You may have to manually add some links back because it's moved all the links that should make the risk event, this delivery overrun, a logical predecessor. It actually left that as a open-ended activity. So it was an oversight on their part the way they linked these. And if you go into our overview of how it links them, we go into a little more detail on that. But actually all the logic is running through this risk summary bar, so the building demolition. So if I added the building demolition as a successor to the risk event, it would do that. You can call Oracle and tell them, hey, that's a bug, they should fix it. Anyhow, moving on. So what I want to do now is place what if scenarios on those activities if I can. Now if I can't play what ifs on those, I'm going to have to look at alternative means. I may have to go into my quick risk template and find some ways to do some things. I may have to look in here and say, you know, is there anything I can do to expedite these chains of activities? Because, you know, there's only two activities that give me massive impact. So what I would do is right now I would save the project and do a save as. And when I save as, I would go into the plan menu, plan information, and actually do mitigation scenario 1, or what if scenario 1 is the plan title. So plan and plan information. Change the title to what if 1, or what if we're going to do, you know, whatever the title is that makes sense relative to this plan. And you can start making these changes here. And then you rerun the analysis, reanalyze the histogram, reanalyze the tornado. So in terms of how this works, similar to the histogram chart, you've got your menu bar across the top. You've got different items. Your task sensitivity settings, we've already set those by right-clicking on the activities and running it to the predecessor. So that's set for you. You can copy your graph, your statistics, and all of that. Your view menu, same thing. It switches your tabs. So you've got different tabs at the bottom. So what we're going to go into is, well, what does each tab mean actually? And then after that, what do the numbers mean next to these things? Because I think that's where a lot of people really get tripped up. So you've got these options at the bottom. What types of tasks do you want to display? So right now we've got normal tasks and risk summary tasks. We've got our show the top 10. I can increase that. We can show the top 15 if we want. We can ignore the negative values. So we can manipulate how that looks. Now the small numbers at the bottom, you're going to get really very little value from messing with those. So on the right hand side, you've got your statistics. The 5 tabs, duration sensitivity and cost sensitivity. You read them the same way. And it says by definition up here, it's the measure of the correlation between the duration of an activity and the duration of the project or a key or key task. What this is looking at is actually the duration of decontaminate structures versus the duration of the final report, or the whole project leading up to the final report. It's looking at the correlation between two items. Same with the clean strip out activity. It's going to put that on one axis. It's going to put the reporting milestone on the other axis. And basically it's looking for a correlation between the two. The cost and the duration sensitivity are read the exact same way. And this gets really confusing for people because this is a statistical correlation it's looking at. So it's saying, wow, I see one going up when the other is going up. Oh, I bet one is driving the other. It's very difficult to explain the numbers to people. Sometimes we'll normalize these numbers so that we put them on a scale from 1 to 100 because people get confused that they don't add up to 100. Sometimes we'll remove the numbers altogether. We can go into the format graph options, and we can actually we can take it out so we don't even show the values, or we can normalize the percentages. So that was right-clicking on the graph, clicking Format Graph. The drawing options, the second tab, and I can change how this looks. So if I wanted to normalize it, it would be on a scale from 1 to 100. If I wanted to remove them, it doesn't even show the values anymore. So now I can just tell people big bars are bad. Little bars, not as bad. But I'm going to walk through what these percentages do mean. So this will account for both the duration sensitivity and the cost sensitivity. What these values are actually showing me is a correlation between one item and another item. So say for example one activity versus mechanical completion. You're basically saying, are their durations correlated? Do they move in the same direction? Because if so, I bet one is driving the other. It's very difficult to explain this to people, but generally when you show them a tornado chart, say 0030 structural steel and painting, 47%. So I'm looking at 47%. and that's driving the entire plan. You can see that in the title. So it's going to put entire plan on the x-axis. I'm going to look at structural steel on the y-axis. And basically I plotted out 50 simulations. And you can see based on the way this plots this out, 0030, the cost is on the y-axis. The total cost of the project is on the x-axis. When I look at this, I can look at the slope of the regression line or the best fit line, and because it's trending up and to the right, I can see a correlation. And based on the slope of the line, I can, and there's different correlation metrics it uses, but basically based on the slope of the line, I can see it's trending up and to the right. And it's about a 47% statistical correlation. I did this in Excel just to demonstrate this. Normally when people see, oh, when one goes up, the project goes up, that makes sense. If this doesn't make sense, it may as we show you a couple more slides. I did some mitigation. So before it was $800,000 to $2 million for the structural steel and painting. So that's 47%. She said, well, we need to mitigate that. So we were able to take it to where it was 800,000 to 1.2. So whatever our mitigation steps were, that's another conversation. By doing that, now you'll notice no matter where structural steel and painting seems to go, it's not really affecting that best fit line or the regression line. It's staying fairly flat and constant across there. You're only seeing very little slope, less than a 2% correlation. When you look back on this chart, the second to last item, structural steel and painting, is 2%. No matter what structural steel and painting does, I don't see it having an impact on my total cost. So the next section, this is what 100% correlation would look like. $1 for $1. There's no risk anywhere except for structural steel and painting. When it goes up $1, the project goes up $1. When it goes down $1, the project goes back $1. That's 100% correlation. If you call us, we can hand you out a set of slides that may help you to get these to get this explained to people. So call us at our PRC offices and we'll gladly pass you some slide decks, because we really do want people to explain these correctly. So you can really see based on that regression line what that correlation metric means. Now, once again though, if you get into a statistics class in the middle of your analysis, you're dooming it for failure, because it's simplifying it and say big bar's bad. It's almost a better way to go. Then people realize, oh, I need to focus on the stuff at the top. Don't get caught in the weeds. Don't get caught in the number and what it means too much. Yeah, it's important to know the higher that number, the more impact it's having, the more it's driving. But we want to use, it's not the percentage of time these are critical or the percentage of time it affected us. It's a correlation metric that's showing if it's driving. It's showing if it's having impact. So you want to use terms like impact, driving, not percentage of the time. Now, that's for duration sensitivity and cost sensitivity. When we switch to criticality, we are looking at the percentage of the time that this is on the critical path. So we run simulations, and you'll look, some of these like board approvals, it was only on the critical path 82% of the time. So these top 4 activities, they were on the critical path 100% of the time. Then we notice there's some critical path movement, and not all the activities then are on the critical path all of the time. So now based on the way my project is scheduled, based on how I'm calculating the critical path, this is on the critical path for the overall network. So these are all the drivers, and it's saying, these were saying the duration and cost sensitivity, was it doing impact? Now this is saying, was it on the critical path as it was being calculated by the software tool? The cruciality, the next tab, all it does is multiplies those two together. And it says, I'm going to take the duration sensitivity, multiply it by the criticality. So it's how much impact was it doing, and was it on the overall critical path? So you'll notice decontaminate structures 67%. The duration sensitivity was 67%. The criticality index was 100%. So 100 times the 67, you're basically getting still the 67%. But now when you look at something like procure third-party contractors, that was at 26%. but it was only 82% on the criticality rating. So now when I look at the cruciality, it's actually gone from 26 to 21%. So that's what this one means. Sometimes I don't generally look at this one because I'm really looking at, I want to know what's driving the milestone. I pointed to the milestone for a reason. I want to know what's pushing out that milestone. The last one is the schedule sensitivity index. And the schedule sensitivity index is useful for the entire plan. And it's actually, it takes the criticality index, much like cruciality would, and it multiplies it versus the ratio of the standard deviation of one task versus the standard deviation of the project duration. So this one is good for the entire project only. The way we're pointing to an activity and really looking at a key milestone or key activity, duration sensitivity is really the way to go. If you are looking at the overall project and everything drives to the overall project, schedule sensitivity index then might be perfectly fine. Generally, when I'm running an analysis, we've put milestones in the schedule for a reason. I want to see what the drivers are up to that milestone, and then go from there. Run my simulations based on that. So I recommend duration sensitivity, but as long as you know what they all mean, they're all good for different scenarios. It's based on the way your project schedule was put together. So this is where intelligence on the risk analyst's head is. This is where that comes into play. So know what they all mean and use the correct one and explain it properly. It's another one, if you can't explain this well, or you get too caught in the statistics or the numbers, people don't look at what the data means, and then they dismiss the whole exercise. So in terms of pulling the graph out, once again, right click on the graph, you can copy the graph. If you right click on the statistics, you can copy the text and you can put that to Excel. So we can get this into Word or Excel really easily. That's an overview of this. Like I said, this is one of the most difficult charts for a lot of people to explain, but it's expected on every risk analysis. So if you do have problems with this, this would be something you could give us a call. We really want to make sure you guys explain this one correctly because it's critical. If we're going to take it to the next step and be proactive and do what if scenarios, I've got to be able to intelligently and easily explain what this means.